this ugly looking integral will have the cleanest solution that you have ever seen. So make sure you watch this video till the end. If you observe carefully, the denominator is a polynomial in x of power 3, whereas numerator is a polynomial of power 0. That means the power of numerator here is less than the power of denominator. And such a pattern is seen in integrals by partial fractions. I've created the full length video. If you also get confused on when to do partial fractions, please do watch the attached video on the top right now. It's the best explanation of when to do partial fractions on the entire YouTube. I promise you won't regret it. If I want to summarize that video, there are really two conditions of when to do partial fractions. Condition number one is power of numerator should be less than the power of denominator. And condition number two is that the denominator should be in terms of factors. So let's try to convert or factorize the denominator. In order to factorize this, let's factor out x from these two terms and let's see what happens. So if we take factor x, so we have x and you'll be left with 1 minus x squared, and with respect to x. You could further factor this and write it as 1 minus x and 1 plus x, but I have a better way to do it. What you instead do is just multiply and divide by x, and we'll be at an easier version of partial fractions at that point. Let's see how does that happen. So if we multiply and divide by x, so multiply x in the numerator, in the denominator this will become x square, and I'll have 1 minus x square with respect to x. The moment you put x square is equal to u, the differentiation of x square is a linear term which is present in the numerator. So this becomes extremely easy at that point to evaluate. So let's do that. So let's say we put x square is equal to u. So the moment you put x square is equal to u, let's differentiate both the sides with respect to x. In order for us to be converting that integral from the x world, we'll have to convert it to the u world now. So if we differentiate with respect to x, differentiation of x square is 2x. Differentiation of u with respect to x is du by dx. If you notice this carefully, there is x times dx over here in the numerator, and there is that x dx getting generated over here. There is x here and there is dx here. So what you do, just multiply the dx on left hand side and take that 2 on right hand side. So you will have therefore x dx is equal to du divided by 2. Okay, so now we can convert that integral from the x world to the u world. So let's see what happens. So that will become integral of that x dx is nothing but du divided by 2. Okay, and that x square times 1 minus x square. So x square is nothing but u. So you will have u, and that 1 minus x square is 1 minus u. Okay, that 2 is constant, can be taken out of the integral. So you will have 1 by 2 integral of du divided by u times 1 minus u. So now let's apply partial fractions over here. So in order to apply partial fractions, you can say let, so express that term 1 over u times 1 minus u as a over the first term, which is u, plus b over the second term, which is 1 minus u. Now once we find the values of a and b, this becomes extremely easy to solve. In order to find the values of a and b, let's just multiply, cross multiply over here. So we have a times 1 minus u plus b times u divided by u times 1 minus u, and in the left hand side we have u times 1 minus u, and this term will get cancelled right here. So you will be having 1 is equal to a times 1 minus u plus b times u. Now what most people will do in order to find the values of a and b is they will compare left hand side and right hand side. It's not incorrect to do that, but what I tell you is it's extremely inefficient. In order to find the values of a and b, you simply just assume some random values of u. What do I mean by that? So let's say if I put u is equal to 1, if I assume u is equal to 1, this term will become 0 and you will get the value of b. Okay, so let's assume u is equal to 1 to start with. So if you assume u is equal to 1, we get 1 is equal to, so we have a times 1 minus 1 is 0 plus b times 1. So you can easily say b is equal to 1 from here. How easy was that? Find the value of b. Now in order to find the value of a, assume some other value of u. Let's say if we put b is equal to 0, so this will become 0. So if we put u is equal to 0, this will become 1 is equal to a times 1 minus 0 is nothing but 1 plus b times 0. So here easily you can also say that a is also is equal to 1. How easy was it to find the values of a and b? You can really assume any values of u over here. The only thing you have to remember is try to, in order to make your calculations simpler, try to put the values of u which will make at least one term is equal to 0. Okay, so that's how you find the values of a and b. Now you can substitute those values of a and b in the original partial fractions over here. So you have, therefore, in fact, you can substitute directly it into the integral. So this integral now can be written like this, but with the values of a and b that you found out. So that integral, let's say that integral is I. So the integral can be written as, there is half outside first. Then you have integral of a over u. Okay, so you have a over u. So you have 1 over u, and then you have plus b over 1 minus u. So plus 1 over 1 minus u. And obviously we are integrating with respect to u. How easy it is now to integrate this? In order to integrate this, it's very straightforward, because we can just give the integral to both of those terms. So we have integral of 1 over u with respect to u plus integral of 1 over 1 minus u with respect to u. Okay, now we know 1 over 1 over x, the integral of 1 over x is nothing but ln x, natural log of x. So integral of 1 over u with respect to u is ln of u, plus integral of 1 minus u is also ln of 1 minus u. But remember, in integral, whenever there is a linear term, you have to divide by the coefficient of x, or coefficient of a variable. In this case, the variable is u. So you have to divide by the coefficient of variable. In this case, coefficient of variable is -1. So you have to divide by -1 after integrating. So don't forget that. Okay. And let's close the bracket, add constant of integration c, and this is nothing but your final result of the integral in the u world. Remember, we have to convert it back to the x world. So the value of u you have to resubstitute. Remember, u was nothing but x square over here. So let's resubstitute that value of u in the end. So we have half ln of x square plus, and this plus and minus will actually become negative. So negative ln of 1 minus x square. Let's close the bracket, plus constant of integration c. You can clean this up a little bit and apply the formula of logarithm. So ln a minus ln b will become ln of a divided by b. So x square divided by 1 minus x square. Okay, by the law of logarithm, you can say ln of a minus ln of b is ln of a divided by b, and plus constant of integration c. And this is nothing but your final result of this integral that we are looking to solve. How cool was that integral? If you understand this concept, can you please consider to like this video and subscribe to this channel? Also, I do post math and calculus content every single day. That's another reason to subscribe. I'll see you tomorrow.